Hey chemistry guys, so this video is going to cover some calculations involving density of gases. It's in chapter 6, as it works for Chem 101 students for their chapter 6 text. This is a topic that I think was not covered super well in the slides, so it very much is worthy of going over in a video, especially 2 examples. So I found 2 examples, or I made this example up. And I made this example up, so these are from my own, from my own brain bread. Okay, let's go. I can do this. So the first question is calculate the density of butane of C4H10 in grams per liter at STP. So what we need to note is that at STP, 1 mole of any gas is going to take up 22.4 liters. Right, and we could also represent it this way. 22.4 liters is the volume of 1 mole of gas at STP. And if we remember, STP is 0 degrees Celsius, which is 273 Kelvin, and 1 atmosphere. So we're given this piece of information here. And I represented this 2 ways because it depends on whether or not you need the mole on the top or the liters on the top. It doesn't matter because remember you could flip this however way you need to in order to calculate your answer. So it says calculate the density of C4H10 butane in grams per liter at STP. So let us look at what we know about butane. Well, they give me the molecular formula. What can I calculate from the molecular formula? I can get grams per mole, can't I? How do I get grams per mole from the molecular formula? I use the periodic table, right? So if I want grams per mole, I need to somehow turn this into grams per liter, right? So this is my given unit. Is it given really? Sort of, in a roundabout way, because they give me a molecular formula and a periodic table. And then I need to just turn it into these units. So grams are fine, but what can I use to convert moles to liters? This conversion up here. So let's start by calculating the molar mass of butane. So it's going to be 4 times 12.011 plus 10 times 1.008. Where did I get these numbers? These are from the periodic table, right? So 4 times 12.011 plus 10 times 1.008, I got 58.124 grams per mole. That's the unit that we see on the periodic table, right? So let's start with our given. We're given 58.124 grams per mole. Right? And I need to turn these moles into liters. That's all I have to do now. The numerator is okay, I just need to turn the moles to liters. So how do I do that? I use the conversion up here. So am I going to use this version where moles is on the top and liters is on the bottom, or this version where liters is on the top and moles is on the bottom? I want to use this version where moles is on the top, because that way I can cancel mole and be left with grams per liter. So let's go ahead and do that. 1 mole of gas takes up how much space? 22.4 liters at STP. And what we'll notice is that moles are going to cancel out. So 58.124 divided by 22.4 liters. That's going to give us 2.59 grams per liter. That's the density. Remember, density is mass per volume, right? I can do any kind of mass that I choose to, grams, kilograms, whatever. And volume, I can do any volume. I could do milliliters, I could do liters. So in this case, it does ask for grams per liter, which is why I use that calculation. So that's how we do that. This one's a little more direct. let's do the other sample question that we did in class, another one of those. And it says an unknown gas has a density of 1.25 grams per liter. What is the molar mass? So let's look again at what units we're talking about. Let's straighten you out there. Here we go. So let's talk about what units we have. We have grams per liter, and I would like to go to, what's the units for molar mass? Grams per mole, right? So I'm trying to go from grams to liters to grams per mole. So let's start with what we're given. 1.25 grams for every 1 liter. And how am I going to turn these liters to moles? Use this conversion, right? Same conversion. 1 mole takes up 22.4 liters. So do I want to have the liters on the top or on the bottom for this scenario? I would like the liters to be on the top. Why? Because I need these liters to cancel out. Plus, if it's 22.4 liters for every 1 mole at STP, my final unit is going to end up being grams per mole. Liters will cancel out. My final unit is grams per mole. So let's go ahead and calculate that. It's just 1.25 times 22.4. We get 28. So we'll say 28.0 grams per mole. That is the molar mass. So you see, these equations aren't nearly as daunting as they seem to be. All you have to do is have a pretty good grasp on this conversion here and know when to use it. So of course you'll be given this conversion, of course you'll be given the STP conditions. So what you just really have to practice and know how to do is how to utilize them. Thank you.